Now, quite frequently, we know a particular ratio and we want to know from what angle it comes. Then you have to use what is called the inverse trig ratio. Let's have a look at the screen where that is explained. So knowing the value of the ratio uniquely determines the angle. Let's take an example with the sine of A being equal to 0.5. Then we know that angle A must be 30 degrees. Now, how is that written? It's written with this inverse notation. There's a little -1 there as a power, and we actually pronounce it as inverse sine. So we would say in this case inverse sine of 0.5 equals 30 degrees. Some books use other notations, like one book might use arc sine, and that's how that is pronounced, arc sine 0.5. I don't particularly like that notation. There's another one, inverse sine. That's sometimes the way that is written. But I like this notation because that's the one that's used on the calculator. Now, where exactly is that inverse key? Well, to access it, you have to press the inverse button there, or sometimes called the shift button. So if I wanted to get, for instance, inverse sine 0.5, I would press the shift button first, then go to the sine key, press in 0.5, press is equal, and I get 30 degrees. Now on the screen I've got some more difficult examples, but basically it is entering the numbers and using the inverse sine or cos or tangent key and then press is equal. So let's have a look. Here in this example we have to find the inverse sine of 0.8 to the nearest degree. Let's do that one first. I press it in on the calculator. You will get 53.130 and a lot of other decimal places. You round it to the nearest degree, becomes 53 degrees. For the tangent, inverse tangent, so it's a shift tangent key, put in 0.7333 and it comes up with this decimal equivalent of degrees, minutes and seconds. That is equal to 36 degrees, and to convert this you again have to use the degree, minute and second button on your calculator. And I say have a look at your manual and see how that needs to be done, because it can be quite different for different calculators. Let's now have a look how we can use these inverse ratios in practical problems. So I've got a triangle problem here and I want you to find the angle. There we've got triangle X, Y, Z, and we want to find the size of the smallest acute angle correct to the nearest minute. Well, the smallest angle will always occur opposite the smallest side. So being the longer side there, that is side 8. So obviously the angle we want is Z, angle Z. For angle Z, we know that the tangent is 6 divided by 8, because the tangent is opposite over adjacent. So that will be written down here. We've got the smallest angle being Z. The tangent of Z is equal to 0.75. Then we have to use the inverse tangent. And if we press inverse tangent 0.75, we get 36 degrees and 52 minutes, because we have to get it to the nearest minute.